Okay. Welcome everyone to the Illinois Energy Now SEDAC Library Energy Walkthrough. My name is Andy Robinson. I'm an engineer at SEDAC offices in Champaign, and we're going to talk today about energy use in libraries in Illinois and incentive programs that are available to help reduce the cost of new equipment, and some examples of some libraries that we've walked through, how they're using energy and how they're saving energy. This webinar will be recorded today and posted to the SEDAC website along with the slides. Hopefully everybody has audio working just fine through the computer or through the phone. Looks like we have about 10 viewers today, and welcome to everyone. If anybody needs to use the chat box to ask a question, it should be in the upper left-hand corner, usually, of your screen. And you might be in full screen mode by default. If you don't want to be in full screen mode, you can hover over the top of the screen and select window mode. But let's go ahead and get started today. Illinois Energy Now is a program run through the Illinois Department of Commerce, and it's a partnership of the Energy Resource Center in Chicago, MIA, the Midwest Energy Efficiency Alliance, and the SEDAC offices in Champaign at the University of Illinois, and the 360 Energy Group that are housed in Chicago as well. And that's a public-private partnership between these organizations that, for instance, the 360 Energy Group is a private organization that helps pull in private sector partners to perform some of the energy audits and some of the retrocommissioning projects. So it's a good public-private partnership throughout the state of Illinois that covers the entire state. What we do, our free services through the SEDAC program are outreach and training, webinars such as this, in-person presentations, energy assistance and assessments, which we'll focus on today, new construction design assistance, which we have some examples of today as well, new construction incentives, energy performance contracting support for larger projects that might have energy performance contracting, retrocommissioning, and application assistance. Here's a picture of some of the SEDAC folks down at the office in Champaign, from SEDAC in Champaign and 360 Energy Group. We cover the entire state of Illinois with audits. Here's a photographic of something around 1,700 assessments that we've done throughout the state over the last 10 years plus. So quite a lot in Chicago area, but really covering throughout the entire state in the population centers and in rural areas. Just a brief mention of where the energy efficiency portfolio standard, where the funds come from for these programs. The top up here, ComEd and Ameren and NICOR and Peoples collect on everybody's bill. There's an energy efficiency rider, and 25% of that goes to the Department of Commerce for the Illinois Energy Now program. Those go towards public sectors, government buildings, K-12 schools, community colleges, public universities, and we also have a sister program that does low-income affordable houses, affordable housing PHAs. If you were a private business, you'd be under the ComEd or Ameren programs for businesses, residential homes, and nonprofits. SEDAC covers all the public sector clients here, and again, there are programs for homeowners and for private businesses and nonprofits like churches or soup kitchens or nonprofits. But today we'll talk about the DCEO Illinois Energy Now public sector section. So briefly, some of the electric incentives. We have a sheet on our website that's an overview of all the incentives. So we're going to be touching today on projects that touch on lighting, T12 to T8 retrofits, high efficiency T8 retrofits, LED fixtures for interior, LED fixtures for exterior, LED exit signs, lighting controls, occupancy sensors, daylight sensors. On the HVAC side, there are incentives for room air conditioners, for new chillers, for variable speed drives on HVAC pumps for demand control ventilation. All these are things we'll talk about today. Kitchens probably aren't as applicable to libraries, but for anything that falls outside of these standard incentives, there is a custom incentive of 12 cents per kilowatt hour. So those incentives are available to anything that's running with very unusual hours of operation or outside the norm of what would be in the standard incentives, or if there's a variable speed drive on a pool pump or some other thing that's a little bit more applicable to a library. But those are 12 cents per kilowatt hour. And those are where the SEDAC incentive program, the SEDAC assessment program can make those calculations of energy savings, and that energy savings is what gets applied to the 12 cents per kilowatt hour of savings for custom incentives. There are other partners. We have additional partners throughout the state that can help with some of these savings and incentives, but we like to be the 800 number, or the ilenergynow.org is the one-stop. You can call us, apply there, and find out more about all the programs that are offered. Also, SEDAC.org has the information both for those Illinois Energy Now programs and our specific programs that we're talking about today. Briefly, for natural gas incentives, we'll touch on some libraries that have received furnace incentives, the boiler incentives for going beyond code with boilers, steam trap maintenance we'll touch on briefly. Probably not too much on the kitchen side here, but again, there are custom incentives for natural gas projects of $250 per $2.50 per therm saved. Now, if you're a really big project and you're saving lots of therms, over 50,000 therms, you might be able to get $3.50 per therm saved. Or if you're enormous and you're saving over 100,000 therms per project, then you'd be in the realm of $4.50 per therm. So for these big boiler projects, these big enormous boilers really do take are more capital intensive projects, and the incentives are higher. Briefly, there are some updates to these incentives. There is a $300,000 cap before that's being waived now for all facilities. There were some caps of 75% of total project cost that are now raised to 100% of total project cost if your project has never been in this program before. And for these programs, they have these caps for total project cost, but it's good to note that that can include equipment plus labor. And that could be in-house labor or contracted labor. And if you're unsure about, this is at school buildings, if you're unsure about your school or library, and if you've not already participated in these programs, Lisa Tubner at the Department of Commerce can help, and her contact information is here, and the General Energy website email address is here as well. But you can also call the 800 number, which comes to the campaign offices, and we can help start your, if you have general questions, we can help you there, or more detailed questions can go to Lisa Tubner in Springfield. Illinois Energy Now has the STEP program as well. These are free products that are offered through our partner MIA. And some of these free products include things that save hot water, like faucet aerators, shower heads, and spray valves. But for electricity savings, you can get free LED exit signs, free indoor LEDs, vending machine controls, occupancy sensors for lighting, or screw-in LED bulbs. Now, this just involves a quick assessment visit by a MIA engineer, and they'll come and they'll tally off what low-hanging fruit items you are applicable for, and then the site, you would be responsible for installing these equipment or having someone install these equipment, but the equipment is completely free and provided through the STEP program. So IllinoisSTEP.org is the website for that program. And you can do a STEP assessment and a SEDAC assessment. SEDAC will then just be a little deeper dive into the building and the building energy systems and the HVAC systems. But we encourage people to go through both programs. Here's the flyer for STEP with their IllinoisSTEP.org website. There's also a boiler program, which we're talking about right now, being that winter is coming and winter is here. So boiler tune-ups can be paid for through these programs every 3 months, every 3 years, or every 36 months. So you can get a boiler tune-up every 36 months, every 3 years. And this covers generally 75% of the boiler tune-up, although there's some exceptions where it can go up to 100% of the boiler tune-up cost, up to $1,500. In addition to boiler tune-ups, this covers pipe insulation and steam trap surveys if you have a steam system, steam trap repair and replacement, boiler reset controls for the temperature of the system, shut-off air dampers, parallel positioning controls, O2 sensor optimization. So most of the typical standard tune-ups that you can do to a boiler are incentivized through this boiler program. I have an example from some school districts that have gone through this boiler tune-up program. And in this example, they tuned up 23 of their boilers in 3 elementary schools and middle and high schools. So the cost was $45,000 for this district to do this boiler tune-up program. But after incentives, it was only $6,000. But they're saving $7,000 a year. So that's this less than a year simple payback for return on investment. Sort of similar story with pipe insulation. And there's some schools that have damaged or missing pipe insulation, and that's also a safety hazard as well. So replacing that pipe insulation, repairing it, in this case was $25,000, $6,000 after incentives, and they're saving about $3,000 a year. So a 2-year simple payback. So this is saving energy and making buildings safer. So these are covered under the boiler tune-up programs, and you can find more information at ILEnergynow.org, or you can Google Illinois Boiler Tune-Up Program, and that'll take you to the same place. I wanted to give everybody an example of another HVAC savings project. Now this is a small HVAC project with the Normal Public Library, and maybe medium-sized project. They in 2010 they had this replacement of an existing 40-year-old multi-zone heating system that had air conditioning and heating going on at the same time. It had 10 different zones to different areas of the building. So these had 10 different ducts and 20 different actuators that were all supposed to be balanced and not fighting each other to deliver air throughout the building. But as you can imagine, this system was in desperate need of maintenance and repair, and heating and cooling was happening simultaneously. But what they ended up doing was this really elegant solution of 10 basically residential furnaces and air conditioners. So there's this lineup here of all the different units, and you can see they have PVC pipes. So these are condensing units, so they're above 90% efficient. And they were able to implement this. They don't have a maintenance person on staff. The head librarian is the head of the library is in charge of these equipment. So he is able to, on his phone, on a smartphone, have basically what you'd have for residential control of your house air conditioning for setbacks at night. But he just sees 10 different zones for the 10 different areas of the library. So able to schedule everything on the phone, able to call that up if there's a problem or if there's an event that needs to change. A very simple setup, a very simple system, and much less complicated than a large computerized control of a system that tends to have problems in its own as well. So the install cost $190,000, cost after incentives $140,000, and but $38,000 a year in savings because of how inefficient the system was before. So that puts this system in the sort of 3 or 4 year payback range, which is a lot faster than most HVAC projects. Typically an HVAC project will be 10, 15 year payback. But in this case, they were just having so much difficulty with the existing system that the savings was even greater. I just wanted to have a brief mention about how efficiency is working in the United States overall. So this yellow line on top is the total energy consumption in the US. And this includes buildings, residential, commercial, industrial, and transportation. But you see the energy savings really tapering off here at 100 quadrillion BTUs of energy per year. So, and we're even dipping down below after the recession, and we've recovered pretty well, but we've really had this period of pretty stable energy use in comparison to the rises that we saw in the 60s and 80s and 90s. And this is due to energy efficiency. This is due to building energy codes, ratcheting up. We're building homes that have insulation. We didn't have insulation in homes in parts of this graph. Car efficiency standards have increased. Industrial efficiency is increasing. And all of these really add up to be a more efficient economy and more efficient use, even while buildings have been continued to be built and people continue to buy new cars. Energy efficiency is working. So this is a very hopeful figure. Brief examples of some of the equipment that we'll see today. We'll talk about HVAC systems, rooftop units can vary in size, chillers can vary in size, many different types of boilers that we'll focus on today, controls, whether it's pneumatic controls or computerized controls or controls on your cell phone. We'll start talking about lighting, fluorescent and LED lighting, and certainly motors and pumps are a vital part of HVAC equipment as well that use energy in buildings. Top 10 strategies for libraries specifically that we've come across are upgrade lighting and existing controls for lighting, evaluate humidification needs. Libraries specifically tend to be built having humidification sometimes, and that's not always necessary. Programmable thermostat setbacks, so setting back at night during hours of operation that aren't needed. Using computer power management, think of all the computers that are on in many libraries and all the screens that are just running idle. Install vending occupancy controls if they're vending machines. Demand control ventilation, so that's varying the amount of ventilation in a building based on the occupancy level. Upgrading to high efficiency HVAC. We're starting to get more expensive as we go down this list. So although an HVAC tune-up is probably not as expensive, but developing an energy management plan and installing variable frequency drives. So in these HVAC categories, they become a little bit more technical, a little bit more involved, but looking at hours of operation, looking at ways to turn equipment down, all these can help save energy in buildings. And we talk about renewables as extra credit. So after you've done the low-hanging fruit, after you've saved money on these other items, then there's an argument to go towards putting solar on the roof, for instance. And we're seeing small systems being put in frequently. Lots of schools are getting small demonstration systems, and libraries would be a good case for demonstrations as well. The costs are coming down in recent years. In recent years, we've been seeing public facilities looking at power purchase agreements, looking at doing essentially a lease, sometimes zero money down, a long-term 10 or 20-year lease of the roof space for solar. And this is especially applicable if you've just put a new roof on. Here's our former implementation coordinator, Holly Nelson, standing on the new roof of her church, and they installed 10 kilowatts of solar right after putting this new roof on. But again, keeping in mind that power purchase agreements going forward seem like a good option. They've been happening on the East Coast and West Coast, where energy is more expensive for public facilities, and we're starting to see them in the Midwest now as the cost of solar comes down as well. So those are things to keep in mind for the future. There's not a whole lot right now going on without, not a whole lot of examples, but just in the last few months, we've been hearing about some projects that are planning to move forward with that. Ongoing commissioning is a thing that we're just going to touch on briefly. So this can require a full-time energy watchdog, nights, weekends, and holidays. So this is really applicable to larger libraries that have the ability to maybe bring on staff that can look into turning things off on nights, weekends, and holidays, or have the ability to turn things off when you're not around. And really, and this could be an occasional person that comes in over the later night hours and puts eyes on dampers, valves, VFDs, boilers, chillers, and plug loads. So the question is, what is really happening when no one's in your library? What lights are on? Is the emergency lighting that's left on, is that necessary? Or could it be reduced as well? Taking a camera and walking through at 9 o'clock at night can be really interesting to see after everybody's shut everything down, what is still on, what's still running, feeling which fans are still blowing air, looking at which dampers are still open. So there's potential for 10% savings at least, and probably 25% savings in some buildings. We find buildings that are on 24/7 that didn't realize it. Sometimes building automation controls will default or will have a bug in the system and turn on at midnight. And so everything seems like it's off at 9 o'clock or at 6 o'clock when people leave, but then it might come back on at midnight and people don't know. So ongoing commissioning really has to do with keeping an eye on those kinds of things, even once you think they've been tuned up, but continuing. Here's an example of an air handler that had the schedules reversed. So at night, it's heating to a nice temperature, and during the day, it's setting back in the wrong direction. So this is an example of it just had day and night reversed. It wasn't terribly uncomfortable. This is the reheat coil, right? So the reheat coil is open at night and closed during the day. The VAV damper up here is constantly at the same level. So that's the variable air volume damper. So this should be varying through the day and the night, but it's just constantly at 100% full open damper. So if you imagine sitting in your office and the air damper over your head is just fully open, blowing cold air at you the whole time, there's a reheat coil there to reheat that air. But this was causing an uncomfortable situation for the building, and it was also in reversed. It was reheating more at night than during the day. Also notice this outdoor air damper is at 40% constantly. So this really should be varying. It should be at least turning off to 0 at night. But during the day, we'd like to see that outdoor air damper vary with the amount of people in the building, whether it's based on carbon dioxide or based on estimates of how many people are in the space, which we actually have a pretty good idea of usually. Here's an example from a library that we worked with where we were able to get the average kilowatt demand, which was a pretty interesting detail to look at. So in this example, we're looking at the average of the weekdays throughout the year is the blue. The average of the Saturdays is the red. The average value for Sundays is gray, and holidays are yellow. So we're seeing a nice reduction. So this is 150 kilowatts in the middle of the night, pretty consistent use. And then it's rising up to average of about 300 kilowatts during the day. But it's nice to see that the holidays are reduced. But the question would be, what is even running on these holidays? So could this be further reduced? Looking at the time of day that things turn off in the evening. So a weekday normally turns off around 9 p.m. A weekend seems like it turns off about 6 p.m. But an interesting case in this example, Sundays, the library closed at 2 p.m. So an interesting question would be, why was the schedule not changed to reflect that 2 p.m.? So that would be a significant savings on Sundays. But for all these holidays, looking at why are the holiday values so high, are lights being left on or coming on automatically, are fans being left on or coming on automatically, and ways to save further. So that deep dive is something that we can do in reports when that data is available. So tip for every report we do, we start off with utility data. So we might ask for 24 months of utility data, and on the top here we have the blue for electricity, and we can see the amount of electricity being used throughout the year. We've compared that to cooling degree days. In this case, this was a library. We've put this cooling degree day line down here a little bit to illustrate that we think that we know that this library had a lot of electric humidification. So we're trying to illustrate that this is not typically what we would see in a building, and this electric humidification is using electricity in the winter beyond what we would normally see. And then air conditioning wise, it's using more in the summer than we'd expect as well. On the gas side, notice how much gas is being used during the summer here in the trough between the two winter peaks. And this is excessive reheat. So this is that example where the VAV valves were stuck open and it's having to do a lot of reheat. So it's fighting, the air conditioning is fighting with the reheat, and we're running boiler and chiller at the same time in these cases. So that's those are some of our first indications to look for before we go on the site visit. Another way to look at different libraries, to compare different libraries to each other, is to take that year's worth of energy. And in this case, electric is blue and green is gas. And this is 50 or so different libraries that we've looked at throughout the state. and it's ranked in order of energy use per square foot per year. So the lowest energy use down here below 50 is doing pretty well. And then the high end over here is around 200 kPa2 per square foot per year. You could also look at the line, which this red line is dollars per square foot per year. So if a typical building was around, let's say, $1 a square foot per year, or a low energy building, maybe typical is $1.50 to $2. Notice how we have some buildings that are in the $2 or $3 per square foot range, really using a lot of energy per square foot, a lot of dollars per square foot. So this is one thing, as libraries come in for an energy audit, we can put them on this list and compare them to their peers. Briefly, just an energy cost breakdown that we do with our reports, looking at how much is being used in lighting. So in this case, 19% for lighting, 22% for cooling, 26% for heating, and over here, fans and pumps. If you add these two together, we're getting in the 17% range. It's another big chunk for fans and pumps. So this is where making sure that the lights are off at night, making sure the fans and pumps are turning down at night as possible or being set back. That'll help save on the cooling and the heating costs. And we have a small slice for exterior lighting. We'll touch on that a little bit. Miscellaneous equipment would be computers and plug loads, most likely, and servers. There's a slice for steam humidifiers here. This one's 4% of their energy use. And we would argue that this is probably $6,000 of unnecessary energy use, since steam is really only needed, humidification is really only needed for rare book rooms, which this library did not have. I wanted to mention briefly some of the new construction projects that we've had. Here's an example of a new construction library for DEKALB library. And this was a historic building. I think the part on the right here is the historic building, and then they're putting a 2-story addition, and it's going to total about 64,000 square feet. Now, in this case, they're going well beyond code. So the new construction incentive program is an incentive to design and build a building beyond code. So there's this savings for going beyond code on electricity, and savings on gas, an incentive for going beyond code on gas. In this case, they did a whole building energy model, and they went so far beyond code that they were able to apply for the high performance design bonus. So an additional savings. So in this case, $50,000 to encourage this project to not value engineer out these beyond code energy savings measures. The total energy cost, they're going to estimated to save 23% on their energy cost compared to what the baseline was. So this is an excellent potential project. And I have some photos. Okay, here's a photo of what it used to look like turn of the century. And notice the lighting. So hopefully the lighting's been, we're going to improve the lighting in this building, and dramatically different examples here now. Here is the one of the new atrium spaces that was built to match to mesh in with the old library. Here's the ribbon cutting for part of that space, and adjacent to that space is this beautiful research room. One of the interesting details in this research room is, notice this whole ceiling is lit by LED tile lights. So that's pretty impressive new use of LED lighting technology that we don't see too often, but it's really beautiful here. Just a brief overview of the plan of the building. Here's this atrium space on the right, and the area with that ceiling grid that we just saw, the lighted ceiling grid, is off to the lower right corner here. And on the left side, we have another area lit in that same fashion, and then stacks and book stacks with more standard fluorescent lighting in those areas. So some existing building energy audits. We're going to touch on some. We're going to flip through sort of random selections from Schaumburg. It's a beautiful building in this picture, Champaign Public Library, and this is a library in Clinton that has both a historic section and new additions. So to not pick on anybody too much, this is going to be a random sampling from lots of different buildings. Here, this library has an overhead view that shows nice white roof to help keep things cool underneath and reduce the heat island effect. And notice all these little dots. These are all skylights, which we have a photo of here in a second. So these are solar tube skylights throughout the reading room area in this library. There's also some skylights over the stairways. And here's what the reading room, the second story reading room looks like. So we have both fluorescent lighting in this case, but notice these square grids. In this case, these are the solar tubes that are coming down. And these fluorescent lights have dimming ballasts that can dim down as the daylight increases outside. These are probably at about 50% power right now. So at night they'd be brighter, and on a bright day these have a nice dim to them that you don't even notice because they're the solar tubes are integrated across the space pretty well. So it's a really excellent use of daylight harvesting. Here's a different library which could do with some daylight harvesting. So notice the existing skylight here. It's very pretty. But notice also all of these fluorescent lights that are remaining on. And our recommendations would be to install a daylight harvest sensor and have these lights turn off when not necessary. In this example, we have this beautiful library space, and this has 32-watt T8s in this case, and they felt like they had too much light in their space. They'd done some analysis with a light meter, and their light levels were higher than they needed to be. They were closer to 100-foot candles when they can be in the range of 20 to 50-foot candles. In this case, the ballasts that they already have are capable of driving a 25-watt T8. So going from 32 to 25-watt lamps, the lamp is slightly more expensive, but each one will save energy. And it'll provide a nicer light level for them as well. In this case, they also, this building had these interesting kettle fixtures, which do a good job of boiling water, but not a great job of lighting the space below. So you see these lights, they're lighting the ceiling with metal halides in these fixtures, but not doing a very good job of sending the light down. And in this space, they have plenty of daylight. So again, daylight harvesting would be a good recommendation here. And these are the ballasts in a closet. Interestingly, all these ballasts were all located off to the side of these fixtures. But replacing these with LEDs would be a good option in this case, especially a sort of a specialty case like this, where they really do want architecturally to keep these historic fixtures, but since they're just aiming up and doing sort of a diffusion on the ceiling, LEDs would work just fine in that case. Here's an example of measuring light levels at a computer workstation desk here, and they're in the 40-foot candle range, 40.3. Again, over 100 would be excessive, but 20 to 50 is a good recommendation. Along the wall behind there, all these spotlights that are facing the wall, these were all incandescent lights. So going to an LED bulb, if even specialty par 16 lamps are available now, but screw-in LEDs are available for these as well. So certainly you can still highlight artwork and highlight displays, but going with LED would make a lot of sense. Emergency lighting can be turned off more than just every other fixture. This illustration is a hallway that just shows every other fixture staying on all night long, and really only one fixture or two fixtures in this whole hall need to be on. So keeping an eye on how much emergency lighting is on at night is another area to save energy for all the hours of operation that you're not even open. We mentioned a little bit about LED lighting inside. LED T8 retrofit, so the 4-foot linear T8 bulbs. There's been some hurdles historically. They're not incentivized through the Illinois Energy Now program, partly because of some of these hurdles. In the past, they were very costly. They were $90 just a couple years ago per lamp. We've seen some that are in the range of $7 per lamp now, so that's getting over one of those hurdles. There's also reduced savings going from a 32-watt T8 to a 17-watt LED, where we just had an example where they were at a 25-watt T8. So the savings gets eroded, and that just means that the cost is going to have to be even less to have a good payback on these. But probably even the biggest problem historically has been reliability. And there's been some bad equipment that was initially brought to market, or there were maybe fly-by-night companies that came around and were doing offering retrofits out of the back of a truck in some stories. So, but what's going to happen? What happens if it fails prematurely? You want to make sure you have a warranty and a reputable company. Or what happens if there's a legitimate short or an electrical problem, possible fire issues? For instance, if you remove the ballast, then it would just be getting line voltage. What happens if someone puts in a T8 lamp in its place? So there's some definite questions about keeping the existing old fixtures and this potential for someone putting in a fluorescent bulb back in. Some do have a dual drive. They could run with a ballast or without a ballast. But then the question we would ask is, that ballast is just wasting energy and getting warm and heating up. So it's probably not an ideal situation either. So really, new fixtures is an ideal situation. Sometimes there are retrofits to existing fixtures that are DLC listed, Design Alliance Consortium listed. But really, new fixtures is the way to go for LEDs at this time. Exterior LEDs, we see exterior LEDs quite a lot. The directionality works pretty well. You can aim them. You're on a tall enough pole that you get a nice light spread on this picture on the bottom here. You can see nice bright white light on the left versus the yellow high pressure sodium that was there before, and probably a better coverage of the spread as well. Another big advantage is that LEDs can be turned off and turned back on, so you could have a motion sensor in the parking lot. You could turn off just a certain row of the lights that are maybe the farthest from the building, and then have them turn on as motion is detected. Or many libraries turn off after 9 p.m., after 9 or 10 p.m., a couple hours after closing. And why even have lights on in the parking lot all night long? And especially if you had a motion sensor, that would be an indication for police or anybody. If there's somebody lurking around in the parking lot or driving through, that would be a visual indication that lights coming on would be that somebody is there. But savings to 50 to 60% are pretty typical in outdoor LED, both parking lots and buildings. Server rooms in the library. So we sometimes we have pretty massive server rooms in libraries and data centers nowadays. These can be pretty big energy hogs, can use quite a lot of energy in libraries. Sometimes up to a quarter of the energy can be used in one closet or in one room by servers. So looking at server virtualization, essentially where some of them go to sleep and some stay on but can handle multiple queries at a time. Offsite servers may be more efficient and maybe our maintenance savings as well. Having a separate HVAC system for that room is important so that you're not conditioning the entire floor or the entire area just for one room. And it's potentially raising the temperature of those rooms. And all these can really be addressed in the data center expert program, which we have here. So the Illinois Energy Now has a data center program. It's in the ComEd service territory only at this time, but these are experts that can come in beyond what we would provide even a SEDAC report, and they can do an analysis specifically on a server room for a library. I would love to see the library that was associated with the server room, so that's a rather large image there. But looking at heat rejection, looking at making sure the cooling units are appropriate, looking at hot aisle, cold aisle, really more detailed analysis for server rooms. Computer power management for computers in libraries. So existing computers we're on all day in these examples, and changing the computer power settings to sleep or hibernate mode is recommended. You can save $30 to $50 per computer per year by going to sleep after 20 minutes. Some libraries have thin client computers instead of a full computer. That's a pretty big energy savings as well. But anytime we see screensavers on in this day and age, modern flat panel screens do not need screensavers. That's a leftover of big CRT monitors. And people presumably now are savvy enough on computers that they can go and move the mouse to make the computer wake up. We see people put little signs on top of the computers that say, this computer is asleep, move the mouse. So sometimes a little sign can save something like $30 to $50 per year per computer. Just think about how many computers are on in your library right now. Oops. Some boilers are large, talking about boilers in buildings. We talked a little bit about what some of the energy savings programs, the boiler tune-up program, that can talk about O2 oxygen trim controls. Looking at new boilers is an important aspect of these programs. In this example, here's a medium boiler example. So going from large to medium to small. Here's an ancient small boiler that's being cut out of in this boiler room. And here is what it was replaced by, something smaller than a refrigerator. So this was a 20,000 square foot building. This new 94% condensing boiler freed up a lot of space in this room. Now it can be used for storage for other things. And it's saving about $2,000 a year in this case. The black lines on these monthly bills are the savings that this new boiler achieved. Hybrid boilers is a little bit more of a detail about putting in condensing boilers in addition to the standard efficiency boilers that might already be there, especially if they're newer boilers. You can do the two together, and these high efficiency boilers can take the bulk of the hours of the load of the year, and some pretty significant savings there as well. Some libraries have very large HVAC. This is an enormous air handler in the basement of this library. Here are some of the steam humidification controls that they have. So whether it's steam or electric humidification, can be really incredibly expensive, and they tend to be a maintenance problem and frequently fail. But according to the American Public Library Handbook, humidification systems are generally only needed in spaces that house delicate collections. So it's really not a necessity for books that are in general circulation, and they frequently fail and break anyways, but when they're operating, they're really using excessive amounts of energy. Steam traps, I think we mentioned in the boiler program that there's steam trap assessments and steam trap surveys that can help look for failed steam traps. Up to 30% fail and open is pretty common. Some examples of large chillers and cooling towers. There are potential for savings on these systems, especially as they're older and very much less efficient. The caveat there is that in Illinois, sometimes cooling is a lesser of a load, depending on which area you're in, what your climate zone is. So really looking at an assessment is helpful to look at how much energy you're using to compare to how much energy you might save. A little bit about air sealing, some interesting photos that were done during a renovation of a space. This is the wall to roof area, and notice the large air gap that's here. And then it's been spray foamed after our report. And so excellent air sealing savings in this case. And it's a pretty inexpensive thing to do, especially when the ceiling tiles are down. But even with the ceiling tiles up, it's interesting to stand on a desk and stick your head up into the ceiling tile area. And if you see daylight somewhere up there, those are areas to get the spray foam out and start sealing those gaps. That's something that can be an interesting and eye-opening experience. Here's a building that was having cold complaints. This is a thermal image of a wall on a winter day. So this is the interior space, and notice everywhere where the metal stud is 64 degrees. Now this building was built relatively recently. It should have been built to code, but it was not, and they did not put the continuous insulation layer that code requires. And if you can just imagine sitting with your back against this, near this wall, all of these cold studs added together are just absorbing, just absorbing heat from your back and causing a very uncomfortable situation. Similarly, this window, notice the double pane window is not really the big energy loss in this case. It's the frame, this aluminum frame that's not thermally broken. And these are areas where you'll see condensation, where you'll see freezing happening if it gets cold enough. And in this case, it's getting down to 41 degrees, so that's certainly going to be condensing. That's below the dew point. And these are not easy to change once the building is occupied. Once the walls are up, you're hard-pressed to make changes to this space. So making sure buildings are built right the first time is important, built to code. So in summary, our SEDAC programs are here. They're in place to help identify energy-efficient solutions throughout the state of Illinois. We like to be the first stop for Illinois Energy Now questions. We help man the 800 number. We can answer general questions. We can point you to either our assessments, or we can point you directly to the incentives that you might be eligible for if you're know exactly what projects you're looking to do. There are trade allies throughout the state that are private sector partners to help make change. A lot of lighting contractors, a lot of HVAC contractors are trade allies in the Illinois Energy Now program, and they know how the incentives work, and they can help you fill out the incentives as well. There are lots of examples of people who have taken advantage of these programs on our website. We have case studies on our website. We have a library tech sheet on our website. All of these are available, and we can send links to those in the follow-up email to this webinar as well. So get your building involved in the energy assessments and the retro commissioning programs and the new construction design assistance and incentives. If you're looking at building a new construction or building a large addition to your libraries, these are all programs that are available for you, and energy incentive programs that can help you save energy and help pay for these projects. Here is our 800 number, phone number, and our website for the Illinois Energy Now program. If there are any questions, I can stay on for a little bit. You can use the chat box to chat some questions to us. You can certainly contact us by email, and we'll have follow-up information in the email that comes out with my contact information and general location for applying for our services or applying for Illinois Energy Now incentives. And looks like we've had about 10 or 11 viewers today. So thank you very much for joining us. And I hope to have everyone either follow up with questions that have questions about incentives, or to apply for energy assessments that we can help everyone identify energy savings in their buildings. I might stay on for just a couple more minutes and see if anybody has any questions. But if you have to take off, I wish you a happy holidays, Merry Christmas, and have a good weekend this weekend. We have some links that have gone out in the chat box to some of the programs, the STEP program and the boiler tune-up program, and some thank yous from Amy, and you're welcome. Thank you very much for joining us. I don't see any other questions, so I think I'm going to stop the recording and stop the webinar. So thank you very much for joining us. Bye-bye.